everybody, and welcome back. I'm your host, Abby, and on this week's episode of What's the Word Eagle Alumni Spotlight podcast, we are joined with Gaurav Nene. And Gaurav, why don't you give us a little bit of background about yourself?
Yeah, so I am a recent graduate from Embry Riddle Prescott campus. Graduated in December of last year, and then I went straight to work at a company called Relativity Space out here in Long Beach, California. The company itself, it's a kind of a late-stage startup that's developing a medium to heavy lift launch vehicle called Terran R. Rocket is designed to deploy next-generation telecommunications, and it's supposed to be a competitor to SpaceX's Falcon 9 launch vehicle. It's a partially reusable vehicle with the booster being reused and an expendable upper stage. Throughout my time at Embry Riddle, I've been working on rockets ever since my freshman year, so this is kind of a dream job. I'm straight out of college at least. Specifically at Relativity, I'm part of the mission reliability team. So our group's whole focus is to answer the question, will this rocket work? And we work with everyone from engineering to customers to essentially guarantee mission success.
Wow, and that sounds like a really exciting job. So, is there a lot of math and engineering principles involved in that?
There's a lot of, first principles analysis. And so part of our, job is to essentially provide some sort of independent verification to a lot of our vehicle engineering teams. So oftentimes we'll work with teams like propulsion, fluids, avionics, and dig through their analysis, go through their designs, and essentially do verification at minimum. And then ultimately what we do is we go in and we figure out, well, where would these designs fail? And then we try to come up with different designs or improve the design to mitigate those failure modes.
Oh, that's awesome. But real quick, I want to circle back to your time at Embry Riddle. Do you have a favorite memory you'd like to share with us?
Yeah, so basically starting my freshman year, I started a small group on campus called Embry Riddle's Suborbital Reusable Vehicle Group. We basically were developing high-powered rockets and launching them at the Mojave Desert from 2019 to 2024. The whole project culminated with a launch in November of last year where we launched a two-stage solid-fuel rocket to 100,000 feet, which I believe currently is the Embry Riddle Prescott altitude record. And so that vehicle, it hit Mach 3.7. We recovered it on land, using a parachute. And that was sort of the culmination of 4 years of designing, testing, launching, breaking rockets, and then ultimately recovering one. So that's probably my favorite memory, and then working with that team, which was really an extraordinary group of people.
Wow, and that sounds like a great memory to have. Very exciting, and something that I'm sure you could take and build upon at your job now.
Yeah, for sure. I mean, everything that I've done professionally has been rocket related. So before I started at Relativity, I interned for a summer at SpaceX for the Falcon 9 Stage 2 group. A lot of the same principles about building a rocket that I had, learned there over the summer, I applied to Relativity. And, ultimately my passion for rockets, got started with at Embry Riddle with this group, the SRV group. Having the experience of, designing, manufacturing, then flight testing, doing that all with a four-person team, you get to wear a lot of hats. You get to have a lot of great experiences across all aspects of the rocket. So everything from, for example, doing, CAD modeling, FEA analysis, to machining, and then all the way to actually getting this thing on a launch pad and flying it. That experience, I think, set me up for ultimately what would be my career path, which is, what I'm doing at Relativity.
Right, right. And so you mentioned CAD modeling and FAE. So what are those for people who maybe aren't engineers?
Yeah, CAD modeling is essentially just it's computer-aided design. So we're basically creating 3D models of what we'll ultimately manufacture. And then those 3D models are sort of like the virtual parts and assemblies that ultimately get manufactured. With those 3D models, we do all sorts of analysis on them. So, for example, FEA, finite element analysis, which is analyzing a structure, applying loads, and then figuring out how the structure would respond to those loads. So think like forces and pressures and temperature and all that. And so, that's a standard practice in the industry, but getting the experience to do that on something that ultimately needs to fly and needs to work in flight, which is what the SRV team did, I think that's a great experience because it's no longer just a classroom assignment. It's something that feels very real. And so the level of, I guess, care that's taken when we did those kind of analyses and when we did that kind of modeling, it was inherently more serious than just a classroom assignment.
Right, right. Okay. And now switching back to your professional career, I know we touched on it briefly, but what does a typical day look like?
First thing that we kind of demands is that we have a broad understanding of the vehicle's design and where it's at right now. So, the first thing I'd essentially do in a day is track down open risks that we have for, certain components on the vehicle. So, for example, right now, the company's going through engine development of our, liquid methane, liquid oxygen engine called Aeon R. And since that's currently a development, since we're going through a development program, there's a lot of open risks there about, how will the design hold up in testing? How does the manufactured articles, what do they look like? And so first thing I do is essentially, tracking risks across various systems. But then some of the more interesting stuff that I do is conduct what's called hazard assessments. So we'll look at the broader picture, like the whole vehicle, like let's say, for example, stage one, and we'll come up with sort of a, failure tree. And we'll essentially look at all the ways that, the stage of the rocket can fail. How can it blow up? And then those hazard assessments often will do that in conjunction with NASA. So recently I was presenting to NASA at John C. Stennis Space Center in Mississippi, regarding a hazard assessment on stage one of our vehicle. And so that's a great opportunity, I think, to, meet with other people in the industry, talk with the regulatory side, which is, NASA or the FAA. So yeah, between, essentially failure modes analysis and risk assessments and hazard assessments, that's pretty much, what my job looks like. And in all that, there's a lot of technical work in terms of figuring out how a rocket can fail and then figuring out how to fix it and make it more robust.
Okay. So there's a lot that goes into everyday kind of work for you.
Yeah, a lot of technical work and then a lot of interfacing with various teams, right? So not just engineering, but also, regulatory affairs, and there's also management that has to be involved, right? Because ultimately, these risks to our vehicle are also risks to the company. They're financial risks that can expose the company to some pretty devastating consequences. I mean, for example, each rocket, it's $100 million or so in terms of development effort, materials. And if something goes wrong, and if we have catastrophic failure of an entire rocket, well, the company is exposed to enormous financial risk. So we're interfacing with a number of different, teams across across the organization. And that's where writing actually plays a big role because we have to essentially, tailor what we say to the various audiences.
Right, right. And that leads me right into my next question. Do you do a lot of writing in your everyday job?
Oh yeah. Yeah, it's actually something that I don't think at Riddle we totally get an appreciation of is the amount of time spent on just communication and how important communication is. So yeah, a lot of my writing is focused around like technical presentations. So that would be like, for example, like in engineering terms, like preliminary design reviews, critical design reviews, where we're either presenting on a system and we're presenting its risks. And in that case, the important thing is, we have to essentially lay out two things, which is the severity of a failure mode and the likelihood of this failure mode happening. And we're writing essentially, talking about, how bad can something fail? And then what's the probability that it will fail? There's numbers involved, but because relativity is in the development phase for our launch vehicle, we don't actually have all the numbers. So we have to somehow give a risk assessment without exactly putting a number to the probability of failure. And I think that's where a lot of my writing time goes. It's sort of qualitative assessments. So other than technical reviews, we're doing failure trees. So a lot of diagrams where we're essentially creating a sort of like a cause and effect diagrams where we're talking about there's failures can be caused by this and what are the effects of those failures. So some of it is documents, think like big sort of just stacks of paper, and the others are just very detailed diagrams. That's typically what my writing looks like.
Right, right. Oh, okay. And now in your writing, is it more important to be very concise and to the point, or would you say word choice doesn't play a huge role in it?
The difference between getting approval to test or launch at a NASA or Space Force base can come down to just a few words. Basically, when we're defining the the severity, or essentially the how bad a failure can be. We have those two, buckets, severity and likelihood. And the most severe types of failures are ones that, result in catastrophic damage to not only our hardware, but also, let's say, test infrastructure and whatnot that NASA owns. And so the difference between categorizing something as highly severe versus moderately severe, it's just a word, right? That's the difference. But it can make all the difference in terms of being able to, like, would NASA allow us to test something that they consider a very high likelihood of failure and highly severe in terms of the type of failure versus if it was moderate. And so we have to be very judicious about our word choice.
Wow, and that really does make a difference, especially when your whole job is centered around creating these rockets, and a few words could make or break it, really.
Essentially conveying risk in a way that is concise and realistic. So I think the one of the more interesting ways that writing is part of this job is I consider it like a technical narrative, if you will, where we're ideating like these scenarios of how a rocket can fail. And it has similar elements to like a narrative where there's sort of like a logical plot to things where we're going through like, a series of events that ultimately lead us to our failure. And we need to build a story around that. First, we need to build a story around how that failure can happen. Some of our failures happen because of human error, operational error. And so we have to put that into words. And then we have to talk about how we think we can catch that kind of failure before it happens, or how we can, protect against it. And it has a lot of similar elements to a narrative, like a story, but it has to be rooted in physics. It's an interesting interplay between those two, where we're creating a story of how something had failed, but it's ultimately there's engineering and math behind it.
Perfect. And now, my last question that I have for you today, do you have any advice for our current Eagles?
Yeah, I think, one of the things that, I wish I'd gotten a little bit more appreciation of before I graduated was just how much experience plays a role in engineering. Obviously we do, analysis. Obviously we do, a lot of first principles thinking, but the difference between what I've seen at least is like a, entry level engineer and a senior level engineer is always the experience that they've seen something, they know how a design is going to behave before they even start building it, so they can see around those corners per se. And, that helps our job a lot as risk managers in a way because, we're always looking at, we're trying to see a little bit ahead of where, the design is. We're trying to understand, how can this thing fail? And, experience helps us do that a lot. So getting as much experience building things and seeing them fail is as important as, learning how to design something to work. A second thing to that on a flip side is that experience can also kind of, I think in some cases hold you back. For example, in our industry, at least in the rocket business, there's two trains of thought currently, which is, using composites versus using metallic structures. And what's interesting is based on the experience of engineers tend to have a bias towards one or the other. On one hand, the bias comes from, hard learned lessons. On the other hand, if we just kind of stick with our experiences, we won't try something new necessarily. So I think there's also a flip side to it where we have to be willing to also, break away from our experience and maybe not rely on that as much, because then that, essentially creates a certain amount of bias towards a design of some sort.
And that is great advice. Thank you, Gaurav. And we want to give a big thank you to Gaurav for being on with us this week on What's the Word Eagle Alumni Spotlight podcast. If you're new to our channel, you can find us on Spotify, YouTube, or Apple Podcasts. And be sure to stay tuned for more episodes.
This podcast is supported by the Department of Humanities and Communication at Embry Riddle Aeronautical University in Prescott, Arizona. Abigail Bradbury is our host and producer. Matthew Haslam is the department chair. And I'm Amelia Chesley, assistant professor of professional writing. The intro and outro music is Wanderer by Alex. Many thanks to the Prescott Campus Writing and Design Lab for hosting our transcripts. Find us where most podcasts are found, and please do reach out if you are a Prescott Campus alum. We'd love to feature you in a future episode.